Hello, stats classes. I will be out all week this week. I had surgery Monday morning, got my appendix out, so um, I'm going to try to be doing some instruction on these videos. So, as you should have your notes out, we're going to be talking about describing data. This can be a new section in your notes. I know I didn't get to finish graphing with most classes. We'll have to wait and get that done next week. But for now, we're just going to continue with the content of this section, this unit. So we're talking about describing data, and there are three things that we're going to, no, excuse me, we're going to write down an acronym. Okay, this acronym is called SOX. We're going to write it this way though. I'm using my mouse to do this, so it's going to be worse than usual. So SOX. Okay. So for SOX, this is what you're looking for. If you look at any type of dot plot, which we've done in class, histograms, box and whisker plots, or um, stem and leaf plots, which we'll talk about in this lesson as well. You're looking at the shape of it, which we're going to describe shape here in a second. You have outliers, which some of you have already used this term. Center, so the very middle of the distribution, which we're going to talk about more. And you have the spread. Okay. So we're going to define all of these. When you're analyzing a graph, we got three things that we're going to look at, or just to talk about with describing data, how it looks. So I'm going to pull these up, and the yellow, of course, is what you want to write for, and I'll give you, after I talk a little bit, I'll make sure everybody has time to write it down. For shape, center, and spread. For spread, the center is pretty straightforward, the shape is straightforward, and we'll talk about shape here in a little bit, and outliers, but the spread right now, we're just going to use the range for that. Okay, there's another way that we're going to measure spread. That's at the end of this unit. So, but for now, it is the range. So if we need to pause the video so that everybody can write it, let's do that. I'll give you a few moments. Okay, so next we want to talk about describing the shape. Okay, so let's go down and we are going to describe the shape. One of the most important parts of stats when you're looking at distribution is its shape. And there's several different types. You have, the first one is symmetric. Leave yourself some space for a definition. The second one is skewed. Oops. Skewed to the left. And then the last one is skewed to the right. All right, so we're going to write down some more definitions on this. Here we go. So describing shape. Symmetric. If the right and left sides of the graph are approximately mirror images of each other. Skewed to the right is if the right side of the graph is much longer than the left, and then skewed left is if the left side of the graph is much longer than the right side. So I kind of have these out of order the way I wrote them on this whiteboard, but just make sure you're getting the right definition in there for each one. And if we need to pause for a second on the video, we can do that and let y'all write it all. So if you look at these graphs down here at the bottom, you'll notice that the different shapes. This one would be roughly symmetric. It's not perfect. Like the left side, here's the center approximately right here. The left side is not exactly like the right side, but that's okay. We use that word approximately mirror images. And most of the time in our class, that's what it's going to look like, is just approximate. Here, this one is skewed to the left because if this is sort of that high point, center point here, this left is longer than the right side. So that one's skewed left, and then skewed right, you see the opposite effect. This is sort of the mode right here, sort of the center. and then you have these outliers up here. So we're using that word outlier to describe that, but it's skewed to the right. Okay. Alrighty. If we look at this example here, this is comparing two groups, and we've done this in our class already, which was when we did the chocolate chips and when we did the memory game. But we didn't have enough data really for that. This is a lot of data compared to what we've been getting in class. And this is talking about household side in South Africa up top, and then in the UK down below. And you can see this one would be described as skewed to the right because you have these outliers, and this right side is much longer than the left side. This one, the UK, is um, more symmetric just because it goes the equal distance both ways. Even though they don't look exactly like, it's approximately. So describe the shape. I've talked about the word center. The center will always be the balancing point. So you imagine that this is one dense figure and you put your finger somewhere so it balances perfectly. So about right here um, is where that center is here. And then here it's probably somewhere between this 4 and this 5. A lot of times it's where the mode is. However, on this one, it's probably closer to here. Okay. Spread. So spread is, we said range. So just for now, but you can see this is about 26 here. The lowest is 4. No, that's a 3. So 23 would be our spread for this compared to the UK, which is from, it looks like 2 to 6. So that's 4. So it's a significant spread of values up here. Okay. Possible outliers, well, we talked about those 25, 15 sort of, but definitely 25, 26. That's a lot of people in a household. Alrighty. Next thing we're going to talk about, let me go down. We are going to talk about stem plots. Okay. So a stem plot is sometimes more effective, or excuse me, more efficient than I forgot to put the T there, than a dot plot. If you have a lot of values, it's sometimes easier to use a stem plot. It's easier to construct and keep track of it. A lot of you said this on the summer packet. So we are going to look at some of the rules for this. I'll have you write down a few things within this, actually most all of it. So how to make a stem plot. I'm going to go ahead and give you a little bit of time to write this down so we can pause the video if you need, if you can. Okay, so we're going to make a stem plot on this next slide. I need to erase all these. Okay. Yeah, right here. Okay. So for the stem plot, this is 20 female AP students. We asked them, how many pairs of shoes do you have? So to construct the stem plot, as you saw in the first step, you need to put all the values that are on the left of the numbers, the larger digit, on that left side. Separate it by a line, and then now these are the stems. That's what that's called. So any of those front numbers, so 1, 2, here's 3, 4, and 5. That's the most that they have. If there was 60 pairs of shoes, we'd have a 6 here as well. Next, we need to go through and find all of these values. How I like to do this is I like to start with the lowest numbers first. So I'm going to start with my teens. Well, you see a 19 happens first, and I cross them out just to make sure I've counted for them. So 19, 13, 13, 13, and 15. You see the second digit is what they've put here, right there, 9. That's 19, 13, 13, 13, 15, exactly what we had. Then we go to the 20s. So we have 26, 26, 24, 22, 23, 23. Those are all the values, and all of those correspond to this. And you have your 30s, 31, 38, here's 34, and then just plain old 30. And there's only one 40 value, which is this 49. And then 50, you have here 50, 57, 50, and 51. Now you don't want to leave them like this. We have to, that was what one of those steps said on the last slide, was you want to reorganize this from increasing, in an increasing order. So you'll see that on this next part. We've moved everything around so it looks like this. And now we've constructed a proper stem plot. And when you're trying to describe the shape, socks, It's kind of difficult because there's not really enough information. You almost wish that you could have gone to the 60s and the 70s to see more about it. But it's hard to say if this is even symmetric. It doesn't look skewed to me. But that's how we need to be thinking about this. This would be, if we drew it like this would be the dots, like right here. Oh, there's just one there. Okay, and then 3, 4. So there's not a lot to show, if that's even a good, you know, plot. But it's sort of, you take this and you turn it into this in your mind. Okay. So the last thing that we need, the last step was that we need a key for these. So there's the key. All you need to do is pick one number. They chose this one here, 4-9. They tell you what it represents: a female student who reported having 49 shoes. So that has to be in context. Have to have that key, okay, whenever you're building these. Now there's two other special types of two ways you can modify the stem plots to make them better. Because right here, I want you to write this on your notes. When data values are bunched up, you can get it. Excuse me. We'll just write this too. We can get a better picture of the distribution by splitting stems. Okay. With two distributions, you want to use back-to-back stem plot of the same quantitative variable. Okay, that seems good. All right, so let's see what they have here. They actually, and usually when you have the two variables, you have males, and this is their shoes. Females, this is their shoes. We just did this one. Now, the purpose of splitting stems, so we're going to start talking about that, is to get a better visual. Remember last slide, we couldn't really tell what it looked like. So when you split the stems, it gives you a better idea about what it looks like. So for the males over here, we split their stems, and you go 0 to 4, 5 to 9, 10 to 14, 10, or excuse me, 15 to 19, so on and so forth. You're making separate ranges for each. You're splitting them. They need to be equal amounts as well. This could have 5 numbers, this could have 5 numbers. Same thing, this is the females. Now we get a better idea of the shape of this just by looking at it. And here, it looks a little more skewed to the right. Okay. So that's how you would want to describe that. Okay. And that increasing order starts from here and goes out on this left side. And of course, you have to have your key. They use the same one from the last slide. Last thing we're going to talk about is a histogram. This is what we are going to use. It's the most common graph. Okay. That uses quantitative values. Variables. We will be using this so much throughout the remainder of the year. And I'll come back next week and we'll craft some more or create some more of these. But it says how to make a histogram. Okay, let's let me get out of this. Keep those. We'll add a slot. So we put a little bit down right there for stem plots, things to write. But now we're going to talk about histograms. This will be the last part of our lesson today. So histograms. So 3 things for histograms. You want to divide the range of data into classes of equal width. Find the count or percent. Talk about that at frequency versus relative frequency of individuals in each class. Label and scale your axes and draw the histogram. Now, a lot of this is how you do it, and you did it by hand, but this is what the calculator is going to do for you. So I'm not going to harp on it too much that you know how to do all this, because I do fully expect that if you have to make a histogram or compare it, you can just use the technology to help you. But anyway, here is an example of the histogram being used. This is percent of residents from each state who are born outside the U.S. Okay. So we are going to have our widths over here, and then our counts. Now the counts aren't something that you'd actually be plotting, or you wouldn't type these into a listen spreadsheet on your technology. This is just what they did. They made the class widths and they went through and counted everybody that's within 0 to 4 or less than 5, and they found 20, and so on and so forth by these widths. So oops, let me go back up to this. It's going to draw it for us, and this is exactly what your calculator would do for you if you wanted a histogram. Okay, that is how you'd make those. We're going to practice that more in class. There's a couple things to keep in mind that I've underlined here, and we don't have to talk about number 4, but there's some cautions. First off, don't confuse histograms and bar graphs. Bar graphs are separated. Histograms are side by side. Okay, there's no gap in between them, but bar graphs have gaps. So that is the difference. So you need to be able to interpret this as a histogram, and if you see a bar graph, know that it's not a histogram. Okay. Next, don't use counts in a frequency table or percents as data. So I said this here. Don't use this as data. Okay. That does not go into your listen spreadsheet. And then use percents instead of counts on the vertical axis when comparing distributions. So instead of putting the counts like they did here, they put counts. It might be more useful to put it as percents, especially when you're going to compare it versus another data set. Okay. So when comparing distributions, let's write that. This last one we don't need to write, but just because a graph looks nice, it's not necessarily a meaningful display of data. Okay. And that is true. All right. So just all these things keep in mind with histograms. All right. And that will conclude our lesson today. Make sure that you're looking at your study guide with this extra time you have. Practicing that, your notes guides, you can get some of those done. But I will be back next week, and I'll probably have another lesson for tomorrow as well to continue this. So y'all have a great day.